Alright, this is Intermediate Notes 5, Algebraic Expressions, Equations, and Inequalities. So let's talk about terms, first of all. Term is the product or quotient of a number or letter or a combination of numbers and letters. So an example of a term is x squared. Another example is 3x. How about xyz is a term? 3 is a term. Terms are separated by addition and subtraction and equal signs, and if you have an equation. A monomial is a single term. Mono means one. So 4x squared is a monomial. Negative 17 is a monomial. 3 divided by x is a monomial. Binomial is when you're adding or subtracting two terms. Like an x plus 2 is a binomial. Bi means 2. Negative 4x to the fifth minus 17 is a binomial. Trinomial is when you have three terms. Tri means 3. So x squared plus 4x plus 4 is a trinomial. 3x to the ninth minus 7x minus x to the negative 1, also a trinomial. The degree of a polynomial is the largest exponent that any one of the terms has. So for example, in this trinomial, the degree is 9. Because the biggest exponent for any given term is a 9. This trinomial, the degree is 2. This one up here, the degree is 1. If there's no exponent, it's implied to be a 1. If you had a single term, like this monomial negative 17, the degree is 0. Not because it's a single term, but because the exponent for x is 0. Because negative 17 times x to the 0 equals negative 17 times 1. Because if you recall, x to the 0 is the same thing as 1. So to sum up, degree is the largest exponent for a variable in any given term. A linear binomial is a binomial that would make a line if you were to graph it. So an example of that would be any binomial that has degree of 1, such as x plus 3. A quadratic trinomial would have a degree of 2. And once again, a linear binomial is going to be a line. Quadratic trinomial, if you graph it, it's going to be a parabola. Let's look at an example. If x equals 5, what is the value of 3x plus 1 divided by 2? Well, this is really just about solving equations, or I shouldn't say that, this is not an equation, simplifying an expression. If you replace the x with a 5 and simplify this, 5 times 3 is 15. Add 1 to that, you get 16. Divide that by 2 and you get 8. Remind you what like terms are. Like terms means same variable, same exponent. So for example, 4xy minus 7xy are like terms. They have the same variables, x and y, with the same exponents. To combine those, you add or subtract the coefficients depending on the signs that are given. Let's look at this example here. Supposed to add x squared, 2x squared, and 3x squared. Those are all like terms because they only have the variable of x, and the exponent in each case is a 2. Therefore, we are to add the coefficients of 1, 2, and 3. It's going to be 6x squared. The x squared does not change at all. Only the coefficients change. Next example. Like terms. Y plus 3y are like terms. same variable, same exponent, plus 2x and a minus x are like terms. So 2x minus x is x, y plus 3y is 4y, so that's what that simplifies to. Distributive property. Distributive property works whenever you are multiplying a number times a sum or a difference. This plus or minus means that this could be a positive, or could be a plus or a minus. Doesn't affect how this works. We're going to multiply the a times each of the terms in the parentheses. Example with numbers, let's say we had 4 times x plus 7. We would multiply the 4 times the x, 4 times the 7. That's the distributive property. So multiplying binomials. Essentially that's using the distributive property twice. You're going to multiply every term in the first parentheses times every term in the second parentheses. Some people call it the FOIL method. It's an acronym. It's kind of weak sauce in my opinion. So let's just go through this. If we multiply x times x, we're going to get x squared. If we multiply x times subtract y, we get minus xy. If we multiply y times x, we get plus xy. If we multiply y times a minus y, you get minus y squared. These middle two terms are like terms because they have the same variables, x and y, same exponents of 1. A minus xy and a plus xy cancel. Therefore, this simplifies to x squared minus y squared. We were multiplying here two conjugates. It's the same thing in each parentheses. The only difference is one has a plus between the terms, one has a minus. When that happens, the two middle terms always will cancel. And you end up with the first term squared minus the last term squared. Happens every time. Number 2 here, this is multiplying the same thing by itself. So this question could have also been x minus y squared. So we got x times x, which is x squared. X times a minus y is a minus xy. Y times a subtract y times an x is another subtract xy. And a minus y times a minus y is a plus y squared. Two middle terms are like terms. They have the same sign, so they're going to get bigger and negative. And that's all she wrote for that problem. Solving first-degree equations. So to solve these, we're going to use properties of equality for real numbers. And those properties are pretty simple. First property, in no specific order, says that you can add or subtract a number to both sides of an equation anytime you want. And the way to write that is if x equals y, then we can add or subtract any number, such as a, to both sides of the equation, and it doesn't change its value. Other property that's extremely important is we can multiply or divide both sides of an equation by the same number, and the equation is still going to be true, as long as the number you're multiplying is not 0. So if x equals y, then we can multiply or divide both sides by number a, as long as a is not 0. You use these properties all the time. So let me just remind you of how you use them. Supposed to find the value of x. So we want to get all the terms with x's in them on the same side of the equation. This minus 3x and this plus x are on opposite sides. We're going to subtract x from both sides of the equation. On the right side of the equation, minus x and a plus x cancel. On the left, we're going to have a minus x minus a 3x is a minus 4x. Now I want to get the 15 and the 3 on the same side, so I'm going to subtract 15 from both sides of the equation. On the left side, plus 15 and minus 15 cancel, so we got negative 4x. On the right side, 3 and minus 15 is negative 12. If we then divide both sides by negative 4, we're going to get x is 3, which is choice D. We use the addition, subtraction, division properties for this problem. Number 2, if x plus 5 is 10, what's x? It's obviously going to be 5, because if we subtract 5 from both sides of the equation, we're going to get x equals 5. Number 3, we got 2x plus 5 divided by 3 equals 9. This fraction bar means division. If we want to get rid of division, we do the opposite. We're going to multiply both sides of the equation by 3. On the left, you're multiplying and dividing by the same number. They cancel. On the right, 9 times 3 is 27. Going to subtract 5 from both sides of the equation. That's going to get rid of this plus 5 on the left. So now we got 2x equals 22. Divide both sides by 2, and you get x is 11. Translating words into math or algebra. So, just one moment here. Ed is 3 years older than Paul. Let's say that Ed is the letter E. Is almost always means equals. 3 years older means 3 plus. 3 years older than Paul. Let's say Paul is a P. So that means that this is translated to E equals 3 plus P. Easy peasy. Paul is twice as old as Mary. Paul is twice as old as Mary. Ned has and is are the same thing essentially, different parts of speech. Different tense, I should say. Same parts of speech, different tense, I believe. I haven't had an English class in a long time. 2 more than Ed, so whatever Ed has, Ned has $2 more. Bill, B, has equals 3 times as much money as Ted. Whatever Ted has, he has it times 3. It's just some examples of translating words into algebra. If you're doing a word problem, and it talks about motion moving in opposite directions, like, for example, 2 objects moving at the same speed start in the same time, move in opposite directions. Or where 2 objects start at the same point, or start at a certain point, a given distance apart, and then moving towards each other at the same speed until they meet. The distance the second travels will equal 1/2 the total distance covered, yada yada yada. So here's what that means. So in one case, they're starting, let's say 1 is going in this direction, and someone else is going in this direction, opposite directions. In that case, let's call this distance 2. Let's call this distance 1. In that case, the total distance is going to equal distance 1 plus distance 2. Makes sense, I think. Another scenario that you have is a couple dudes or dudettes are apart from each other, and they are moving towards each other. Perhaps a little attraction pulls them towards each other, like magnets. In both cases here, once again, the total distance is going to be the distance of one of the people plus the distance of the other. If you have motion in the same direction, so like you got this person starting here, and you got this other person starting here. Person 1 starts early, and they're going in this direction. And then it says, hey, person 2, they're going to start late, but they're eventually going to catch up to them. How long will it take them to catch up to each other? Well, in this case, the distance of each of the people, they have to be equal. If they're starting in the same spot and ending up in the same spot, that means that their distances have to be equal to each other. So keep that in mind. That's going to come up in some problems on the ACT for sure. All right, 2 cars leave a restaurant at 1 p.m. One is traveling east at 60 miles per hour. The other is traveling west at 40 miles per hour. At what time will they be 350 miles apart? So the situation is they're starting at the same spot. One goes east, one goes west. The one that goes east, its rate is 60 miles per hour. The one that's going west, we'll call that rate 1. We'll call that rate 2, is 40 miles per hour. At what time would they be 350 miles apart? So once again, if we go back to this up here, if they're going in opposite directions, the total distance has to equal d1 plus d2. So if you recall, distance equals rate times time. Distance equals rate times time. These little subscripts that I have here have no mathematical value. It just tells you the first person and second person. Person going east is the first person, person going west is the second person. So we know that the total distance is going to equal distance 1 plus distance 2. We were told the total distance is 350. Distance 1, we don't know what it is, but we know it's rate times time. And we know that the rate is 60 miles per hour. We don't know the time. Distance 2 is the rate, which we know is 40. We don't know the time. Now those times must be the same, because they're both leaving the restaurant at the same time. How long will it be until they are 350 miles apart? So the times have to be the same. You combine like terms, and then divide both sides by 100. You're going to get 3.5. Time was being measured in hours for this, so they will be that 3.5 hours from now. It says at what time, not how long, not how much time, but at what time. So if we add that to 1 o'clock, we're going to get 4:30 p.m. Good? Good. Number 2. Gloria leaves home for school, riding her bicycle at a rate of 12 miles per hour. Let me just write down that information. So we got Gloria. The rate of Gloria is 12 miles per hour. That takes care of the first sentence. 20 minutes after she leaves, her mother sees Gloria's English paper on her bed and leaves to bring it to her. So now we got Mom. if her mother drives at 36 miles per hour, so the rate of mom is 36 miles per hour, how far must she drive before she reaches Gloria? Now this doesn't tell us how far they drive. It also doesn't tell us the time. Here's what we do know. The time for Gloria, whatever that is, the time for the mom is 20 minutes less. So it's Gloria's time minus 20 minutes. I really don't want to write 20 minutes because we're talking about hours. 20 minutes is 1/3 of an hour. So I could say this. So once again, to sum up, because there's lots of things going on here. First sentence says that Gloria is going 12 miles per hour. The rate of Gloria is 12 miles per hour. The third sentence says that the mom is going 36 miles per hour. The second sentence says that 20 minutes after she leaves, her mother sees the paper and leaves. So that means however long Gloria has been driving, their mother will always have driven 20 minutes less. So since they're going in the same direction, that's what's happening here. We got Gloria and we got mom. The distances are going to be the same. So the distance of Gloria is rate times time. The distance of mom is rate times time. We can set them equal to each other. Same direction, set them equal to each other. The distance of Gloria, her rate was 12. Her time, let's just leave it as a t. And then the rate of the mom is 36. And the time is t of g minus a third. We're just using t. Well, I'll tell you what, let's get nuts here. Let's do t of g. So when we're done, we know this is the time of Gloria. So, using the distributive property, I'm going to make this smaller here so I got more space. Using the distributive property, if we multiply 36 here, we're going to end up with 36 t sub g minus a third of 36 is 12. If we subtract 36 t sub g from both sides, we're going to get negative 24 is the time of Gloria, equals negative 12. If we divide both sides by negative 24, we get the time of Gloria is going to be a half. Talking about time, talking about hours. So Gloria drove for half an hour. Does that answer the question? No. How far must she drive before she reaches Gloria? Well, we know that Gloria's distance and her mother's distance have to be the same because they're meeting up with each other. Let me label the order in which I did these things. Anytime you do things in an unlogical way on your paper, you want to label the order in which you did it. So to figure out the distance that they traveled, we're going to take Gloria's rate times the time, and we're going to end up with 6 miles. They both traveled 6 miles. Answers the question. Let's move on. Nisha, beautiful name for a boy or a girl, leaves home at 11 a.m. and rides to Andrea's house to return her bicycle. She travels at 12 miles per hour and arrives at 11:30. So let me write down some of this information. We got Nisha, so glad to meet you. Saw you in the school hall, talking to a teacher. The rate that she rides her bike, 12 miles per hour. Took her half an hour to make that trip. So her time riding her bike 30 minutes in hours, that's half an hour, or 0.5 of an hour. Then it says, tell you what, instead of Nisha, so glad to meet you, let's just say bike. Then it says that she walks home. We do not know her rate of walking. We do know that her time for walking, though, she left at 11:30 and got there at 1. So that would be an hour and a half, or 1.5 hours. So it's the same distance. She starts at her house, goes to Andrea's, and then goes from Andrea's back home. So we know that the distance that she bikes has to equal the distance that she walks. Distance is rate times time. So she went 12 miles per hour for half an hour. The rate at which she walked, we don't know, but we know she did it for 1.5 hours. So this is 6 equals the walking rate times 1.5. If you divide both sides by 1.5, you're going to get 4. So she walked for 4 miles per hour. That was her speed. Direct variation. Mentioned this in a previous lesson. Didn't use it much then in that, but we are going to use it here for sure. Direct variation essentially means that you can use a proportion to solve problems. If two things have direct variation, that they move both in the same direction. As one gets bigger, so does the other. The more I eat, the more calories I eat, the more pounds I weigh. The more I run, the less I weigh, both moving in the negative direction. So direct variation is relationship of x with y is going to equal the second relationship with x with the second relationship of y. All right, so example 1. X varies directly as y squared. Well, we can simply write that as x over y squared. And x equals 12 when y is 2. So that's going to be 12 over 2 squared. Pardon me. Hit the wrong button. I do that at least once per video. It's pretty annoying on my end. It's probably equally annoying on your end. So it's 12 over 2. What is the value of x when y is 3? So we want to know what x is when y is 3, and the relationship is supposed to be squared. So it's 3 squared. And I don't have my 2 squared here. So since they vary directly, x varies directly as y squared, and then we're given x and y values, essentially the relationship that we're given is this. It's always going to be x over y squared, and then we're told that these pairs go together. X is 12 and y is 2. And then these two go together. We don't know what x is, and we know y is 3. So it's x over y squared equals x over y squared. It's direct variation. So it's going to be 12 over 4 equals x over 9. 12 divided by 4 is 3. If you multiply both sides by 9, you're going to get x is 27. Wonderful. Inverse variation means that the numbers move in opposite directions. So instead of having the relationship of that we just had x1 over y1, we're going to have x1 times y1 and then x2 times y2. So direct variation, you divide things that are related to each other. In inverse variation, you multiply them together. Let's see how this works. The time t, by the way, distance problems are indirect or inverse variation, because if you're going a set distance, the faster you drive, as that number gets bigger, the smaller your time is. Or if the time gets bigger, that means that your driving rate has to get smaller. So that's an example of an inverse variation. The time t to empty a container varies inversely with the square root of the number of men, m, working on the job. So that's saying t times the square root of the number of men. That is our relationship. If it takes 3 hours for 16 men to do the job, so 3 hours, that's the time, times the square root of 16 equals, how long will it take for 4 men, 4, working at the same rate? I wrote that backwards. Time is first. We don't know what that is. 4 men. So in each case, we got the time, 3, and we don't know. We got the men, 16 and 4. Simplifying this, square root of 16 is 4. Square root of 4 is 2. This is 12 equals 2t. Divide both sides by 2, and you get t is 6. T is measured in hours, so it would take 6 hours for 4 men to do the same job as that's right. So it takes 3 hours for 16 men to do the job. It's going to take 4 men working at the same rate to do it in 6 hours. All right, let's continue. A joint variation. Yeah, let's skip joint variation. Factoring polynomials. Polynomials, factoring, kind of a big deal. So let me give you some of the special rules. Perfect square trinomial. Perfect square trinomial. That looks like this. X squared plus 2xy plus y squared. Let me put this down here. That's always going to factor into an x minus y, to an x plus y squared. Another version of this, the perfect square trinomial, is you have x squared minus 2xy plus y squared. That will always factor into the binomial x minus y squared. Difference of two squares, also very popular on the ACT. So let me just write this in symbols. Difference of two squares. Square minus square. That would be something like x squared minus y squared. That's going to factor into binomial x minus y and x plus y. Lots of other factoring rules, but those are essentially, it's just 2 rules for special cases. So number 1, this is a trinomial. Is it a perfect square trinomial? To be a perfect square trinomial, the first term has to be a perfect square, which it is. The third term has to be a perfect square, which it is not. This is going to factor into 2 binomials. I have other videos teaching how to factor. If you need to watch them, they go in a lot more depth than what I'm going to go into here. If you need to see them, let me know. I'll give you a link to it. So since the lead coefficient is a 1, that means this is going to factor into just x and x at the beginning of each binomial. We take the square root of the first term. Then to determine what goes in these other spots, you need two numbers that multiply to get 2. Same two numbers add to get the middle coefficient of 3. So the numbers that would do that would be 1 and 2. 1 times 2 is 2. 1 plus 2 is 3. So you make one of these plus 1, you make the other one plus 2. Doesn't matter which one is which, and that's factored. Number 2, once again, if you're lucky enough the lead coefficient is 1, these are easy to factor. If you're not so lucky, they're not easy to factor. It's going to be two binomials. Split the x squared apart at the beginning of each binomial. Two numbers that multiply to get negative 12. Same two numbers add to get 4. So that would be a plus 6 and a minus 2. Done. Inequalities. So let me just run through what each of these things say. This says 5 is greater than 1. This says 2 is greater than negative 2, x is greater than 0, x is greater than y. 8 is less than 9. Negative 4 is less than negative 1, x is less than 0, y is less than x. X is greater than or equal to 0. X is greater than or equal to y. X is less than or equal to 0, and x is less than or equal to y. So what are some rules for inequalities? They're the same rules for equations with one exception. If you multiply or divide both sides of an equation by a negative number, I should say both sides of an inequality, then you have to change the inequality sign. So here's what that means. A lot of words. Here's what it means. Let's say we had negative 2x is less than 8. We want to get x by itself. We would divide both sides by negative 2. This is the special rule because we just divided both sides by a negative. So what happens is on the left we get x, on the right we get negative 4. The special thing is the inequality sign changes direction. So instead of a less than, it becomes a greater than. Same thing happens if you multiply both sides by a negative number. Here we would multiply both sides by negative, it's not an equal sign. Let's say that was greater than or equal to. If we multiply both sides by negative 5, on the left they cancel. On the right you get negative 20. And this changes the inequality sign to be x is less than or equal to negative 20. Alright, that was extremely long. I apologize, but I think it was also necessary. Please do exercise set 5, and make sure you tell your mother that you love her.